Introducing the sine law. If A, B, and C are the what? Little a, little b, little c. Are the sides of a triangle, and capital A, capital B, capital C are the angles of the corresponding sides. I don't even know why those blanks are there, right? It's like, seriously, it's like a make-work project. Then, okay, here's the sine law. If you take the ratio of the length of a side and divide it by the sine of the corresponding angle, then in a triangle, those three ratios are equal to each other, right? So if we take little a divided by the sine of angle A, it's the same as little b over the sine of angle B, which is the same as little c over the sine of angle C. And it works in a right angle triangle where you're going to use one of the angles will be a 90 and the sine of 90 degrees is 1, so it just kind of comes out to a bit of a simpler thing. But so here's a proof. Two congruent triangles are shown below. Congruent means same size, same angles, right? Like the same. So these triangles are the same. And we can, what we want to do is say, okay, I've got this non-right angle triangle ABC. We can drop an altitude anywhere, right? Just take the distance from a base, you know, there's three bases, to the opposite angle, right, and get a height. So this is H1. So if we now take this right angle triangle here, right, then we can say that the sine of angle A is opposite over hypotenuse, right? So the sine of angle A is equal to H1 over C. Which means we can rearrange this so we can go that C times the sine of A is equal hi, H1. Okay, that's a C, that's an H1. And in this little triangle here, so we have two right angle triangles, where we can say the sine of angle C is H1, opposite over hypotenuse, which is A. So we can say the sine of angle C is opposite H1 over hypotenuse A, which means that A times the sine of C is equal to H1. So I now have two different expressions for H1, right? I've got C times sine A and A times sine C. So if H1 is this and H1 is that, what can we say about this and that? They must be the same as each other, right? Let's extend, come on, extend the page. There we go. So we can say that means that C sine A is equal to A sine C. And doing a little bit of rearrangement, if you divide both sides by little c, or divide this side by little c, and divide this side by little c, and these guys cross off. And if so what do we got? Let's go with sine A is A sine C. And let's divide both sides by little a. And these cross off, so we're left with the sine of A over little a is equal to the sine of C over little c. Okay, that ratio is true in that one triangle, right? And now we can do kind of the same thing here, right? So again, we have the same right triangle, right, ABC. This time we've drawn an altitude from this base to the opposite angle, C here, splitting this into two right triangles, right, allowing me to say that the sine, right, we can talk about angle A, so we say the sine of angle A is opposite, excuse me, which is H2 over hypotenuse, and the hypotenuse of this guy is B. So that means that B sine A is equal to H2. And we're going to do a similar thing with the sine of angle B. So I say the sine of angle B is equal to opposite, which is H2, over hypotenuse, which in this triangle here is little a. So I can say that A sine B is equal to H2. Well, if H2 is this and H2 is that, what can we say about this and that? They're the same. So we can write B sine A is equal to A sine B. And we're going to do the same thing, right? But this time I'm going to do it in one step. We're going to divide both sides by A times B. So the B's cancel here, the A's cancel here, and we're left with sine A over A is equal to sine B over B. And by the transitive property, right, because we've got sine A over A is equal to sine C over C, and sine A over A is also equal to sine B over B, we end up with, we're going to summarize this all. We end up with sine A over A is equal to sine B over B is equal to sine C over C. Okay, and that's the sine law. And that's not the form you're going to get on your formula sheet. Okay? What you're going to get on your formula sheet is this. So we'll just flip. That's the proof, right? You don't have to know how to prove it. It's a fairly easy proof. So we run through it, and you can say, okay, yeah, I can see how you could do that, right? So what we're saying is, in order to solve non-right angle triangles, what somebody did was say, hey, let's divide it up into a couple of right triangles and see what we got. And let's divide the same triangle as we started into two different right triangles and see what we've got. And then this is what we came up with, right? And then what that says is, so you can write it this way, A over sine A is equal to B over sine B is equal to C over sine C. That's what we give you on the formula sheet, right? And then you can flip it over so that you can write it this way. Sine A over A is equal to sine B over B is equal to sine C over C. Okay, so we give you the top one, you can flip it. And all it really says is that the ratio of the length of a side to the sine of the angle opposite that is the same for all three sides and angles in a triangle. Or the ratio of the sine of an angle divided by the length of the side opposite it is the same for all three sides and angles in the triangle. And that allows us to solve some problems. So here's how it works, right? Cosine law. Okay, if you're going to do the cosine law, you need all three sides, or you need two sides and the enclosed angle, right? So you need side, 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 or side, angle, side, right? So if you're looking at the triangle congruencies, this one is side, 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 and this one is side, angle, side. I've got a side, then I've got the angle in between, and then I've got another side. Those are triangle congruencies, right? They mean that there's only one triangle you can draw. Remember the first day we did triangle congruencies and we tried drawing a bunch of triangles? And we said, oh hey, if all three sides are the same, everybody ends up with the exact same triangle. If we do two sides and the angle between, I say draw me a side 10 centimeters, then draw an angle 30 degrees, then draw a side of 12 centimeters, everybody gets the exact same triangle. One problem with the sine law, now what does the sine law require? So the sine law needs what's known as a known pair. So to do sine law, to use the sine law, And sometimes it's called the law of sines. So sine law or law of sines. Cosine law or law of cosines. Depends on. To use the sine law, you need a known pair, which means you need a side, bless you, and an angle opposite that side. Known pair, right? So that's a side and the angle opposite that side. Okay, and the reason is, I'll come back to that in a sec, but the reason is, when you're doing this, if I know this, if I know this, and I know this, and I know this, then I can solve for this, right? I have 3 out of 4 things I can solve for the fourth. If I know, that's good. If I know this, and I know this, and I know this, I don't have, so a known pair is one of these guys, right? A side and the opposite angle. If I know this, this, and this, I can't solve this, right? Because no matter how I group these guys, I've got 2 unknowns. If I use these 2 here, there's still 2 unknowns. And if I use these last 2, there's still 2 unknowns. You can't solve an equation that has 4 quantities and 2 unknowns. Can't be done. You need to have 3 quantities. Okay, so we need a known pair. We need to know a side, which in this case we have little c. So here, let me just take that off. We have little c and we have angle c. And to solve for the indicated sides or angles, so it's easy to get the third angle, right? Because you know these 3 angles have to add up to 180. They didn't ask for it, but it's trivial, right? You just go 180 minus. Okay, so we're going to set this up. Hang on, I'm just going to bring out a calculator. Okay, so most important thing when you got the calculator is you go to mode and you take it into degrees. Okay, so your calculator will be cleared before a test. You're going to walk in, you're going to clear your calculator on the way in. Then you have to set it to degree mode. Okay, if it's not in degree mode, then I mean, you should find out pretty soon because you're going to get weird answers, right? Like it shouldn't. So you know what? Let me just leave it in radian mode for now. I want to see what kind of an answer we get. Okay, so I'll set this all up and I'll solve it and we'll get the number and then we'll go, huh? Right? Does that make sense? It's part of looking back. Okay, so we want to find little a and little b. Right now we know angle A, so let's do this. So we're going to set it up this way. Little c over sine c is equal to little a over sine a, right? So when using the sine law, you only take a pair of them, right? A and A, B and B, or C and C. So A with B, A with C, or B with C. And what we want to do is, we want to put, and actually, you know what, I should write it this way instead. So let's put the thing I want to find on the top left. So that's what I want to find is little a, and I know this, I know this, I know this, right? I have to know 3 out of the 4. If you're trying to set it up, and it should be a cosine law, when you go to set it up, you're going to go with, I don't know 2 of these things, right? No matter how you set it up, you'll always be saying, I don't know 2 of these things, and you can't solve it. Okay, so let's do a little rearranging. So let's say that A is equal to C times the sine of angle A over the sine of angle C. Okay, so before I put any numbers in, I can just do a little bit of rearranging of the formula. Just say, look, this is the thing I want to find. Okay, and the form of the sine law that you're going to use, which is to say, you know, what's with this thing? Now it's locked out. The form of the sine law, right, depends on what you want to find. If I want to find little a, then I put it up top left. If I want to find angle a, I'm going to put it on the top left, right? It just makes it easier because when you go to do your rearrangements, you're always solving for something. You're always multiplying by something on the bottom and moving it up top instead of having to flip stuff around. Okay, hang on while I pause this because this. Okay, so let's fill in the numbers now, right? So, little a, always do this, right? Put the thing you want to find should be, if I want to find little a, I'm going to put it in the top left. Okay, then I rearrange the formula. So we know C is 3.93 times the sine of angle A, which is 79.82 degrees, over the sine of angle C, which is 32.23 degrees. Okay, so we're just going to put that into our calculator. So we're just going to put that in. Here we go. Calculator, right? Okay, so, oh my God. When last case, so my calculator is in radian mode, which means we're going to get the wrong answer, all right? We're not going to get any answer. It takes so long. Okay, so I'm going to go 3. We're going to wait like at least 3 seconds. Man, let's see if it works faster. You put a bracket after the sign. So 3.93 sine, and it gives you a bracket, right? So 79.82.
Do you need to put a bracket after this?
Depends whether you want to get it right or wrong. If you want to get it wrong, you do not need a bracket. Yeah. There is no choice here because you wanted to calculate the sine. If you don't put a bracket after that, then it's just wrong, right? This is going to be wrong anyways because it's in radians. Okay, but I want to, I want to get something. So the sine of 32.23.
Oh, yeah.
Well, that's what I'm doing now.
I just went straight to the number.
Okay, -5, right? Wow. So that doesn't make much sense, right? It's telling me that the length of side A is -5. You cannot do that, right? You cannot have a negative. Okay, so that tells me there's something wrong here, and the thing that's wrong here is that the mode needs to be in degrees, okay? Now that should just be an automatic thing for you, right? When you do 30-2, you won't have to worry about that because radians is the mode you want. So I'm just going to go second function enter to bring this down. Recalculate. Okay, 7.2 seems reasonable, right? 7.2529, so let's call it 7.3. A equals 7.3. Okay, what units? There's no units on here. Oh, I guess we should give 2 decimals.
There's two.
Okay, so we'll go with 2 decimals on here.
You're not doing significant.
Well, no. But because everything's 2 decimals, I'm going to go with 2 decimals. We don't do sig figs as we would in, like, science. Oh, my goodness. 7.25. Okay. Now, we also want to solve for, okay, so we know this is 7. It's just sad. Okay, now in order to solve for little b, I need to know the angle opposite it, right? Now that's an easy calculation, which one of you is going to do. It'll take like 10 minutes if I try and do it. So what is angle b to 2 decimals, which is what it's going to give you anyway? 67.95. Okay, so we just go 180 minus 79.82 minus 32.23, or 180 minus bracket, and then go 79.82 plus 32.23, right? We get the answer. Okay, so we got that as 67. Now, so far things make sense, right? Smallest angle, smallest side. Largest angle, largest side. This side should be somewhere between 3.93 and 7.25, right? That's part of the look back that occurs anytime you do some math, you want to look back, right? It's like getting that -5 and saying, well, that doesn't make much sense, right? What's wrong here? Okay, and it's, oh, right, it's got to be in degree mode. Okay, so I want to find little b, so I'm putting it up top. So little b over sine b is equal to, and I'm going to go with the stuff that I know, which is the c. I don't want to use the calculated value. Sometimes you can't help it, and then you're going to store it in your calculator or use the full value that's in your calculator, right? In this case, we can use values, so we're just going to set it up, little c over sine c. Before we plug anything in, we're just going to rearrange the formula. Now we can plug in, so little c is 3.93 times the sine of, okay, so now we need b, which is 67.95, divided by the sine of angle c, which is 32.23. So if I can get the calculator back, which is a huge if, then I'm going to hit second function enter, because I've got most of what I need here, and I'm going to try and move this along. Well, I moved pretty quick. So I want 3.93. Okay, and I want 67.95. 67.95. Okay, and then I can hit enter. Okay, 6.83. 6.83. Okay, so write a 6.83 up there. Let's see if we can move this up. Okay, so bless you, the measures we have on the triangle make some sense, right? Got 32 degrees, smallest angle, smallest side. Middle angle, middle side. Not middle really, but in between, right? Largest angle, largest side. Right, so I didn't get something like, oh, I got 10 here or something, and say, oh, that's longer than that side. It can't be, right? Smallest angle has the small side. Just think, as the angle opens up, then so does the length of the side opposite it. Okay, so it's all good, right? So the next thing that we would use the sine law to solve for would be, well, what do we got here? Okay, so what are we doing here? Solve the indicated sign. So first thing you should do is just identify your known pair, right? That's what tells you I'm using sine law, is I've got that known pair. It's going to be kind of easy in today's homework because it's all about the sine law, right? When it comes down to the review or stuff like that, you know, when we're doing a review, when we're doing problems, solving problems, which is tomorrow, so proving sine law, problems involving the sine law. Well, we kind of proved it early, I guess. So the rest of today, tomorrow, is just sine law problems, right? Once we're done this, it's just sine law problems. Tomorrow is sine law problems. Wednesday will be solving problems. That's where you have to figure out, okay, am I using the sine law or the cosine law? What information do I have? How do I set this up? You know, do I have a known pair? So let's call this little f. Let's call this little d. That's the 67 degrees. So what can I solve for? Well, I want to solve for little e. Okay, but you know, to do that, I need angle e, and I've got two unknown angles, so I can't solve for angle e because it's got a side opposite that I don't know, and I can't use the cosine law. To use the cosine law, I need three sides. But what we can do is say, all right, look, this is what I've got, and this is what I can find. I can find angle D. Once I have angle D, I can calculate angle E. When I have angle E, I can combine it, pair it up using sine law, and solve for side little e. Okay. Okay, so we got to go through a couple of steps here, right? We cannot directly solve for what we want to find. So what we can do is we can solve for angle D. So the sine of an angle over the length of the side opposite it, right? Not just think of the sine law as being, in this case, we're trying to solve for an angle, is equal to the sine of an angle. In this case, we've got our known pair, which is angle F and little f. Okay, so that's how we're going to set it up. Now we can do two steps here, right? I want to solve for angle D. So it's D times the sine of angle F over little f. But then D will be the inverse sine of this expression. Okay, so I can go straight there, right? You could also just plug into here, get the sine of angle D. Okay, now you look at that diagram, if you got the sine of angle D, it's going to be a number like, 0.7 or something. And if you look at the diagram, you're going to say, I don't think angle D is 0.7 degrees, right? Which means what I got was the sine of angle D, and I'm going to need to run an inverse sine. Okay, so that's kind of look back. Or go straight there, right? This says, you know what, I've just done the rearrangement. I realize I need angle D. We have to do an inverse sine. It's like using cosine law to solve for an angle, right? You have to do an inverse cos. Okay, so let's fill in the numbers now off of the diagram. So little d is 4.75 times the sine of angle F, which is 67 degrees, divided by little f, which is 5.24. Okay, punch that in your calculator. Might as well make a mistake now, and we can fix it, right? Or you'll get it right now, which is good, and then you'll just say, okay, I know how to do this. So after cosine law, you got a pretty good shot at getting it right. You know what you got to type in. You know you need an extra set of brackets, okay, or not. And then let's find out that, hey, we need an extra set of brackets. Okay, so get an answer. And keep in mind, this is not what we're looking for, right? I'm not looking for angle D. Okay. Mode. Yeah, it's in degrees. Okay, 4. Whoops, gotta move. I got 55.24, should be 5.24. Okay, so what do we get for angle D? 56.56, okay? Anybody got something different? So what you need to make sure is you go sine inverse, and it gives you a bracket, and you got to put bracket 4.75 sine 67, bracket, bracket, right? You need to finish up. You need to evaluate the top expression, so it's got to be in brackets, 4.75 sine 67. You need a bracket before the 4.75, and you need two brackets after the sine 67.
I got the same answer without using the double bracket.
Well, you should use them anyway. You lucked into it. Actually, yeah, you know what? It's going to do it properly. At the very least, you just got to make sure that you close the bracket after the sine 67. Okay. Otherwise, you don't need to. The reason I do it is every time I see an expression with the long division bar, if I throw brackets around the top and brackets around the bottom, I won't get it wrong when it's cosine law, and I have to have them. You know, so if you want to just say, oh, if it's cosine law, I have to have the brackets. If it's sine law, I don't. I'd rather just say, got a big expression bar, put a bracket on the front, bracket on the back, divided by, put a bracket, put a bracket. You know, better to over bracket than under bracket, right? Okay, so D is equal to 56.556. D is not what I want. I will not round anything except for the final answer. The final answer is little e. Okay, and how are we going to get little e? We're going to have to use a calculated value, right? We're going to have to calculate angle E. So angle E is equal to 180 degrees minus the sum of 67 plus the 56.556 dot dot dot. So if I want to work out angle E, I'm going to go down here, pull this up, go 180 minus, that's divided by, that's plus, and now I've just messed up everything. 180 minus bracket 67 plus second function answer. Close bracket. Enter. Okay, 56.44-ish. All right, pretty close, right? Pretty close to the other angle. But not exactly, okay? So we don't want to round this. You don't want to go and say, okay, that's 57 and then this is 56 exactly, right? We need to use this value. We're just going to keep it in our calculator for now. Going to say, I want to solve for little e. Little e over sine of e is equal to, remember my known stuff, right? What was my known stuff? Was f and sine of f. So little f over sine of f. Okay, we're not looking for the angle this time. So little e, just to rearrange, is f times the sine of angle e. Now remember, angle e is sitting in our calculator, right? And we're just going to pull that number back in and use it. Divided by the sine of f. Okay, so now we can go and fill in the numbers. What's little f? 5.24. Okay, so let's go this way. So little e is equal to 5.24 sine of e divided by the sine of 67. Okay, so we have two uses of the sine law. Right? And the reason we have to do it twice, the first time we can't directly find the thing we want to find, little e. So we have to solve for what we can solve for, and the only thing we can solve for right now is angle D. Once we have angle D, we can get angle E. When we have angle E, then we have 3 out of the 4, right? I know this angle, I know this side, and I know this angle. Okay, so I've got 3 out of 4. Okay, on our calculator, what are we going to type in? God. Okay, so here's angle E sitting there, right? So I'm going to go 5.24. I'm not going to do the 5 apparently. So I'm going to go 5.24. I'm not going to do the 4. Sine, and I'm going to put in second function answer, right? So I'm just going to say bring down the number, the last number that was in there, right? And I only need it once, so I don't need to store it anywhere, right? It's not like times where we have to store it because we're going to use it twice. So 5.24 times the sine of the angle that we calculated divided by sine 67. So divided by sine 67. Close bracket. Enter. Okay, and that's little e, right? 4.74. So e is equal to 4.74. And now we can round to whatever. Okay? In this case, we'll go with 2 decimals. So first off, does that make any sense? Well, okay, D was 56.55. I don't know what's up with this board. Okay, so that was 56.55. This angle here was 56.44. This angle is slightly bigger than this angle. That's 4.75. That's 4.74, right? Like, and that's the difference. This is 4.74, rounded to 2 decimals. Okay, really, it's almost an isosceles triangle in the sense these two angles are almost the same, right? But they're not quite. Okay, but then these sides will be very close, right? That's a 4, looks like a 9. Okay, moving on. What do we want to find here? I don't know what we want to find here. So we can solve the entire triangle, right? We've got a known pair. Okay, so we've got little a and angle A. This is little c, this is little b. So we can solve for angle C, right? That's actually all we can do right now, right? All we do right now is solve for little c, or sorry, angle C. Once we have angle C, we can then calculate angle B, right? Because the three angles add up to 180, and when we have angle B, then we can calculate little b, right? And then we will have solved the triangle, right? Solving the triangle, all three sides, all three angles. Okay, well, we got some time. I knew those were going to disappear. Because now they won't. Just messed up smartboard stuff. All right, I'm getting out my calculator because there's no way I want to spend the time working on the onboard calculator, which is not in the greatest of shape right now. Okay, so just checking I'm in degrees is going to clear stuff out. All right, so we're going to do two setups of the sine law. First thing, the only thing we can solve for is angle C. So sine of C over little c, and we're going to use A because that's our known pair, right? I have angle A. So the sine of angle C is little c sine A over little a, and C is the inverse sine of, let's fill in the numbers now. So little c, 18 sine 47 degrees divided by little a, which is 40.3. Okay, I'm doing this on the calculator in my hand. Sine inverse, 18 sine 47. Okay, and you can or may or may not put brackets in if you want them or don't. Okay, 19.066. Okay, and a little bit more. Probably do this to like the nearest tenth because the sides seem to be to the nearest tenth, but then they should tell you. So for, oh wait, angle C, yeah. So angle C, 19.1 degrees. Now, much as I may write 19.1, I'm not going to use that to calculate angle B. I'm going to go 180 minus, okay? So for the angle that I'm going to use, just in your calculator, so you got the number sitting there, just go 180 minus bracket second function answer plus 47. Okay, and you'll get 113.9338712, right? That's the number we're going to use when we do our next calculation, because we only want to round the final answer. Okay, so angle B is 113.9. Okay, that's what I would write out for the answer. I'd write out 113.9, but what I'm going to use is 113.933. Okay. All right, so what are we trying to figure out, little b? Yeah, you'll even hear your name in there. And our known is little a and sine A. Okay. So the nice thing is we only have to use the sine law once to figure out an angle, right? Because that's the pain part is doing the angle because you got to get this inverse sine. When we're solving for a sine, you know, b, c sine b over sine A. Okay, fill in the numbers. So it's 18 sine. Now this number you're pulling out a calculator, right? So second function answer divided by the sine of 47 degrees, and that's equal to, okay, so I'm going to go 18 sine second function answer, right? Pull in the number, it's sitting in your calculator, divided by sine 47, hit enter, 22.4956, so we round that 22.5, right? And that's what we're going to write here is 22.5. Okay, this one will be 113.9. Now, here's the question. Let's say that I used 113.9 instead of second function answer, right? So I went 18 sine 113.9 divided by sine 47, and I get 22.501, so I'm okay, I still would have got 22.5. It won't always work that way, right? Especially if you're just on the cusp of rounding something. So if we were, if the first one was like 22.44, then I would round that to 22.4. And then using this, I might have got 22.45, which I would round to 22.5. And then I'd be off by a tenth, and my answer, if it were numeric response, would be wrong. Okay? You don't want to do that, right? On a diploma exam, rounding incorrectly is going to cost you 1.25% of your final mark in the course. Okay? There's 40 questions on a diploma. It's worth 50%. 50 divided by 40 is 1.25, 1.25, right? And diploma's worth 50% of your mark. So you'll lose, or you can lose 1.25% of your mark. And it's not because you don't know how to do stuff. It's because you rounded incorrectly. So you don't want to lose big marks because you rounded incorrectly. Okay, what else? We've got problems involving the sine law. So we got a few examples, right? We'll take our time. We got time. We've got work period on sine law tomorrow, and then we've got pretty much work period on solving triangles. We'll go through a few of them, but okay. Problems involving the sine law. Sam stands on one bank of a river and looks across to the other side. Peter and Ming stand 100 meters apart on the other side of the river. If the angle between the lines of sight from Sam to Peter and Sam to Ming is 65 degrees, and the distance from Sam to Peter is 56 meters, then determine the distance from Sam to Ming. So the first step is we need to draw an accurate diagram. We need to label it. And by accurate, I don't really mean to scale, right? It just needs to have the information indicated on it. So Sam stands, so we've got two banks of a river. And here's Sam. And he looks across. Peter and Ming stand 100 meters apart. So there's Peter. There's Ming, and this is 100 meters. If the angle between the lines of sight from Sam to Peter and Sam to Ming is 65 degrees, and the distance from Sam to Peter is 56 meters, then determine the distance from Sam to Ming. So we want this distance here. Okay, so looking at this triangle, right, you've got 100 meters and 65 degrees. So you have a known pair. Having a known pair tells you I'm using the sine law, right? I cannot use cosine law here. What I want to find is little p, right? That's little p. This is little s. This is little m, right? Kind of confusing because m is 56 meters, but okay. So what we do is set this up and say little p over the sine of angle p, but then say, hey, I don't know little p, and I don't know the sine of angle p either. So I cannot directly solve for the distance from Sam to Ming. The only thing I can find is this angle here. So we're going to have to do two steps, right? We're going to have to find this angle, use it to get this angle, and then use the sine law again to get this side. All right? So be aware when you're solving problems, you may have to do it in two steps, right? It doesn't always work in one step. Okay, so let's do it. I can find m, so we're going to use the sine of angle m over little m, and my known stuff is the s's, so sine of angle s over little s, right? So you need your known pair, and then you need that third piece of information, which is another side or another angle. And then you say, okay, all I can solve for is angle M. That's it. Okay, let's do a little rearranging. Sine of M is M times the sine of angle S over little s. So M is the inverse sine of, now I'm going to fill in the numbers. So little m is 56 times the sine of 65 degrees divided by little s, which is 100. So I'm going to get angle M, right? I can do that on my calculator, not on the board one, because that'll take forever. So second function, sine inverse, 56 sine 65 divided by 100, 30.4996087, right? So 30.499 dot dot dot. Yeah, sure. So let's indicate that we're not using a rounded value, right? By putting the 3 dots on the end, you just say, I know this thing isn't 30.49, and I'm not going to round it, because then I would get the answer wrong. I'm going to use that number, I'm going to calculate angle P, and then we're going to reuse the sine law here. So we're going to say little p is what I want to find. So little p over sine p, and then we're going to use the stuff that we know, right? We know S, side S, and we know angle S. So that's our known pair. So, oops, gotta write this as little s over sine S. Gotta use the right form of the formula, right? Otherwise things will just go badly. So P is equal to S sine P over sine S. Filling in some numbers, S is 100. Sine, I'm going to calculate this over the sine of the angle that we're given, which is 65 degrees. Okay, so the first thing I'm going to do is calculate, so it's going to be 180 minus bracket second function answer, so I'm bringing in the number that we calculated, 30.499, etc., plus 65. So I get 84.50039913. That's what goes in. So now I go 100 times the sine of second function answer, right? Bring in the angle that I calculated, divided by sine 65, close bracket, enter. And I get 109.82, 98923. So 109.8 meters. Okay, 109.8 meters. Okay, and what did we say? This angle was like 30.5, and then this angle was, what was it I calculated? 100, or 84.5. Okay, now remember, I'm writing these in rounded, but I'm not using them rounded to do any calculations, right? So any intermediate values you use should not be rounded. We only round the final answer. Okay, and then it makes sense that, okay, this is the largest angle, so this side is the largest side. This is 84.5 degrees, that's 109.8, which is 9.8 meters bigger than the other side.
I might be looking at the wrong timetable, but it's supposed to be doing this tomorrow. Since those problems involved in Sine Law.
What are we supposed to do today?
Introducing and solving triangles by Sine Law.
Yeah, let's do it all today, and then we'll just. Okay, make sense? No, you wouldn't use the time anyway, so let's. That's all of you, it's not just her.
Okay.
All right, so. Yeah, not just you. Yeah, let's drive through this today, right? You just copy everything down, then tomorrow will just be straight work period. You can come in here and sit and just work on problems. Okay? If I can get this stupid thing to work. So, yeah, you're right, but what the heck, let's finish it off. Paris is well known, didn't we do one of these? For the beautiful decorations that hang above the streets during the Christmas holidays. One such decoration is hanging on cables as shown in the diagram below. Determine the angle between the cables? Isn't it like 130 degrees? I don't know what angle they're. I guess I'm guessing they're looking for these angles here. Determine the angles between the cables. So we got 130 degrees there. We need to get those other two angles. Okay, so we have a known pair, and then we have one other thing here, so we can use that to solve for this angle here. Okay, so let's label it. What are we going to call this? Let's call this. Let's call that. Call this A, B, C. That makes this little a, that makes this little b, and that makes this little c. Okay, well, to find an angle, we only have to use the sine law once, and then we go 180 minus those two angles, and we get the other angle, right? So, easy peasy. One use of the sine law using this, and then we're going to use these guys here. Okay, so let's set it up. The thing I want to find is angle B, and the stuff I know is A. So sine B is equal to B times sine A over little a. So to go directly to the answer, yeah, I know. Okay, so let's fill in what we know. Little b is 11.7 times the sine of angle A, which is 130 degrees, over little a, which is off the screen, and is 20. Is it 20? No, that's... Is it? Oh, okay. Hey, same question is on the cosine law sheet. Okay, so I don't want to use that calculator. I use this calculator. Okay, what do we got? Second function sine inverse. 11.7. 1.7. Sine 130, close parenthesis, divided by 20, enter. Got 26.62, so call it 26.6. Angle 180 minus 130 plus, second function answer. So we got 26.6 degrees and 23.4 degrees. 26.6 degrees, 23.4 degrees. Okay? So all we need to do, right, is get one angle. Okay, so I can round this because when I go to calculate the second one, it doesn't matter, it's going to be rounded to one decimal place as well, right? The only thing you got to watch out for it is when it's like when there's decimals on here and decimals on here, then you should just go 180 minus and pull this actual number in. So it's still a good idea to pull the number in. Oh no, I pressed that thing, it's not going to... Okay, what do we got? Why can the triangle shown below not be solved using, so why can't it be solved using right angle trig? Because there's no right angle. Yeah, okay, no right angle. And why can we not use the sine law?
Because there's no pair.
Yeah, you don't have a known pair, right? So if you try and set this up, you're looking, you say, all right, I've got this side, right? I got little b, I got little a, but the only angle I have is angle C, and I don't have side C. So no known pair. I knew that was going to happen. So no right angle. And we would need side C. Okay, we can solve this using the cosine law because we have two sides in the included angle. So I could work out the third side, and then I could use the sine law to work out another angle. Okay, so one nice thing, we're not going to do it, but one nice thing about if you have to use the cosine law is you only ever have to use it once. Once you've used the cosine law to find like that side, you can then use sine law because you'll have a known pair. Question?
For this is so do we get the form on the formula sheet? Do we get for cosine loss or side side?
You get the two forms of the cosine law. You just get c squared equals a squared plus b squared minus 2ab cos c. And you get cos c is equal to b squared plus or a squared plus b squared minus c squared. You get all the forms. You don't get all the forms of the formulas, but you get both cosine laws and you get one sine law, but you can always just flip that over. We got to use compass headings here. Captain of a small boat is delivering supplies to two different lighthouses as shown. The captain's compass indicates that lighthouse A to the left is north 30 degrees west. So this is the lighthouse. So what we need to do is draw. This is going to disappear, right? You can always tell. The light line, for some reason, they'll hang around for a few seconds. So I'll just talk until it disappears, and then there we go. Now the line will come in thick. I have no idea why it does that. So north, south, east, west. So north, 30 degrees. Tells us this angle between north and here is 30 degrees, right? And a distance of 9 kilometers away. So that's 9. Lighthouse B on the right is north 50 degrees east. So from north, we go 50 degrees. Okay, and again, that's from north, right? Tells us this angle in here is going to be 80 degrees, right? 30 on this side, 50 on this side. Lighthouse B. If he goes to Lighthouse B first, then determine the compass heading the captain must follow when he travels from Lighthouse A to Lighthouse B. Okay, so again, if we need to figure out a compass heading, we're going to have to look at this and figure out an angle in here, right? And if we figure out, then we can say, well, it's west and then so many degrees towards the north or whatever, right? But that would be figuring out this, and so we'll have to figure out what we can figure out and then use that to solve the problem. If the distance between the two lighthouses is 12, so we know that this side here is 12. We know this side here is 9, and we know now, I'm just going to erase that this angle in here is 80 degrees. Okay, so we have a known pair, right? We got an angle, we got the side opposite it. We can use the cosine law. We can solve for this angle in here. Okay, and then we'll see if we can use that to figure out a compass, and then determine the compass heading.
Which lighthouse?
Okay, so lighthouse A, which is on the left. Lighthouse B. So everybody knows where we got the 80 from, right? Okay, put these back in here. That was north. That was 30 degrees here, and this was north 50 degrees east. So together, these two angles are 80 degrees. Okay, so we're going to work out angle B. That's A. Let's call this C. That makes this little a. This is little c. This is little b. We want to figure out angle b. Sine of b over little b is equal to, and my known pair is angle c inside c. So I got to go sine c over little c. So always put, if I'm solving for an angle, put sine of b up top. If you put it on the bottom, you got to try to cross multiply and then divide everything. If you put it down, if you put it up top, so sine of b is b times the sine of angle c over little c. So b is equal to the inverse sine of, and now we can fill in numbers, so little b is 9, times the sine of angle c, which is 80 degrees, over little c, which is 12. Okay, so plug that in calculator. Second sine inverse, 9 times sine 80 divided by 12, 47.6. Okay, rounded to nearest tenth, 47.6 degrees. Let me just move it using Actually, no, I'm just going to 6, 1, 2. Okay. I'm going to write the whole thing out because we might have to use that angle again, right, in order to find what we ultimately want to find. Okay, so what do we got? So you notice how we have parallel lines here? The east-west line is running parallel. This is 50 degrees. So this angle here is 50 degrees. Okay? Got parallel lines. Like this is 40 degrees here because that makes a 90. So that's 40, the alternate and interior angles, and then these guys. Okay, now we know that the angle between these two guys is 47.6 degrees, right? So this angle here is 47.6 degrees, but this angle is 40. That makes this angle here, the little guy, 7.6 degrees. Okay? So we are going to go west 7.6 degrees to the north. Okay, so the compass heading we need. Okay, west 7.6 degrees to the north. Okay, that's compass heading to the axis. Okay, that's it, right? Done.